solving system of equation by, what's the method, honey?
Substitution.
Substitution method. Okay, so do you want to go over?
Sure.
Okay. So the first one, question is number 1, right? And
yeah.
we already have the answer, negative 15 comma 0. We already check if your answer is correct by substituting negative 15 here, and 3 times negative 15 is negative 45, and then adding 0 is still same thing, and negative 15 plus 0 is negative 15. So we know this is a correct answer, and then you're gonna explain how you did. Okay?
Okay.
So
what I first started it with was I wrote down the problem on my piece of paper so that I would know what the answer was or what the problem was. And then I would pick the one that already has like the problem halfway solved, which was the second one because it didn't have anything with the x.
Oh, you mean the coefficient of x is 1?
Yeah.
Okay.
So then I noticed that there was 7y, so what I did was I subtracted 7y onto the opposite side, so it would be negative 15 minus 7y. And then that like
so
finishes.
This one.
Yeah, so it would
so
turn into
basically that. Can I do this?
Yeah.
So this was given, right?
Yeah.
X plus 7y, that is equal to negative 15, and you basically rewrite this starting with x is equal to.
Yeah.
Right? So subtract the 7y from both sides of the equation, and then you rewrite this thing. And you happen to choose, start with x is equal to because the coefficient of x is 1.
Yeah.
Okay. And then what do I do next?
After that, you would pretty much just pop this part of the equation into where the x would be. So it would be x, or 3 parentheses, 15 minus 7y.
So instead of a 3 times x,
yeah,
you have this nice, beautiful parenthesis. And instead of putting x here, x is equal to negative 15 minus 7y. So you copy this thing here.
Yeah.
Okay. And then plus 21y. Where do you get that 21y?
So
it was here, right?
Yeah.
Just copy. Okay. And then?
After I had placed this in, I multiplied the 3 to both sides.
Apply distributable property.
Yeah. And then that equaled to negative 45 minus 21 plus 21y. Or
21y
yeah,
plus
both
21y.
of them were y. And then that equaled 45, negative 45.
Okay, so that's what you got first.
Yeah.
And then?
And then after that, I put the two y's together, which equaled it out to be 0. And then I added 45 on both sides.
Wait, okay, go
well,
back. I don't understand.
It would be 1.
What do you mean y is equal to 0?
Because
you combine like terms, and then what do you get?
You would just get y.
No.
Well, or would it just be 1y?
No. What is negative 2y plus?
These are both 21.
21y plus 21y is what?
So negative 21y plus 21y is just, it cancels out both the 21s.
So you have 0 comma y?
Yeah.
0 times y, 0y?
Yeah.
So 0 is equal to what?
I don't know. I don't know what 0 is equal to. 0 is equal
maybe
to
this
y.
is kind of confusing here. So you have negative 21y plus 21y.
Yeah.
And I am not convinced from here to here. What is negative 21y plus 21y? Cancel.
Yeah, it cancels.
Nothing.
Yeah.
So we cannot really record this. It's just gone. And what do you have? Negative 45.
So negative 45 equals negative 45.
Yeah.
And
so
then that's...
are we getting any information out of this?
No.
No. That's kind of weird. Because it's not, it's correct answer, but it's not, something is missing here. This is just basically negative 45 is equal to negative 45. And then y, in this case, y can be any number.
So it'd be it'd be an infinite solution. If it's that.
Not yet. We don't know about x. Y can be any number.
Okay.
That's kind of weird. So here's what I want to say. I think it's gonna be infinite in many solution. If y is equal to 0, there's no reason to believe that y is equal to 0. There's no. But if we say, what if y is equal to 0? Then the answer is x is negative 15. So this is one solution, okay?
Yeah.
What if my y is equal to 1? Just bear with me. What if my y is equal to 1?
So it'd be negative 15 minus 7 right there, and then that would be, I think 8.
So can you write that down? What if y being 1? Then what's x?
X would just be negative 8. Or wait.
Yeah.
Yeah, negative 8.
Are you sure?
Or no, it would be going up because of the negative right there. So it would be
negative 23.
Yeah. So x would equal negative. Ooh.
So let's just plug it here. You said x being, sorry, you said x being negative 23.
Yeah, so x being negative 23.
Wait. X being negative 23, and you plug here.
Yeah.
Then what do you get?
You would get 23.
Negative 23 plus the 7 will get you negative 15, right?
Yeah.
And plug the same thing in here if you got actually same thing.
Okay, so negative 23 times 3
is negative 69.
Yeah.
Write that down, negative 69. And then plus 21.
21. Wow. And then that would equal, I don't think that that would equal the same thing. Because
yeah. So maybe we did this wrong. A plus 7, y is negative 15 minus 7 is not negative 23, honey.
Oh, shoot.
That is negative 22. Okay, so negative 22 plus 7 is?
That'd be 14.
Hmm?
Because if 23 times, or plus 7, it was negative 15.
So here, negative 22 times the 3 is equal to what?
66, I think.
Yeah.
And then times 1 would be 21.
Yeah.
So 66 plus 21 would be...
Negative 66 plus 21.
Plus 21 would be...
Negative 45.
Okay. So that one would work.
That one was negative 15. We already talked about it, right?
Yeah, but I think we put 23 in there.
Yeah, so we fixed that. It's 22, right? So now in here, 3 times negative 22 plus 21 times 1 is a negative 45. That's the question I'm asking.
Okay. And we know that that's the answer.
So
Because it does
we
equal
are
out to
having another one. If x is equal to negative 22 and y is equal to 1, we know this is another solution.
Yeah.
Do you think there will be another solution?
Yeah, I guarantee you that they
Yeah?
probably have more solutions.
What makes you think it's gonna be like that? Do you have any reason to believe?
No, I don't know.
I know it's a tedious work, but I want you to come up with another example. Like, we have these two, and can you think of another one? How about I use some other number?
Okay.
The answer is infinite and many solution. And then I'm sorry, the very first one, they throw kind of a weird, funky one like that.
Yeah.
But the answer is infinite and many solution. And I'm asking literally, can you come up with another set?
I know.
Yeah. Do you want to start with a y, or do you want to start with an x?
We could do x equals positive 8.
Yeah, so positive 8, plug 8. Comma.
And then it would be y equals 1, and then you would do, no, because it has to be negatives.
Maybe we can do negative 8.
No, because even then it would just equal out to just be negative 1.
So y, it's negative 8 times 3 is what?
Oh, I'm looking at 15.
It doesn't matter. Even if you go negative 8 here, if you have negative 8 here, this one has to be negative 7. So y being what?
I was thinking 1, but I don't think it would work out at that point. So I honestly have like no idea.
You need to do some busy work, honey.
I know, I'm just thinking. Because 1 wouldn't work, because if we did, God, I did the math in my head. It was 16 and then 17, 18, 19, 24. So negative 24 plus positive 21.
So is there any reason that you pick 8 or negative 8?
I was looking down here because 8 plus 7 would equal 15, but I forgot that it was a negative 15. So
yeah, I don't think this is a good pick. Pick something else. I would pick like a y being 2 then.
We could do
y being negative 2.
And then that would equal to 14.
Yeah, and then we just need one more negative.
So we do negative 1.
Negative 1.
Okay. So negative 1. And then it was negative 2.
Yeah. Okay.
And then that would equal.
So now let's see, negative 1 comma negative 2 would work for the first equation.
So 21 plus 21. Negative, it'd be
40,
a negative. It'd be
2.
Yeah, 42. And then put a 1, negative 1 up here, which would be negative 3, which would equal out to negative 45.
Okay, so we have the 3. And then you know what? I want you to take a look at this first and second equation. And take a second equation, multiply by 3.
So multiply by 3 right here, which would just be positive 3 plus 7y.
No, take the second equation, apply, multiply by 3, both sides of the equation. Then what will you have?
What?
Take the second equation.
This one, yes.
And multiply every term by 3.
So multiply that,
Yeah.
and that.
And then write that down what you will have.
Okay.
3x.
That's 7 times 3. It was. 21x.
21y.
Y. And then 15 times 3 is...
Negative 45.
So it just makes that problem.
Yeah. So what did you discover? If you take this second equation, multiply by 3, you will end up having the first equation.
Yeah.
Another way of saying, if you take the first equation, divide by everything, every term by 3, you will have a second equation. So even though they look different, what's the conclusion? If you graph them, you will have
an infinite.
No, if you graph first equation and second equation,
yeah,
that what do you anticipate when you draw this graph?
That they would cross over at some point.
Not crossing.
They would.
They're
aligning?
Yeah.
Okay.
Because even though they look different, they are exactly what?
The same.
Same. So therefore, the conclusion, we have, let's talk about, we have some condition, let's say x plus y is equal to 10.
Yeah.
How many solutions can you find?
You could do 2, so x would be 2.
2 comma 8.
8? Yeah, so 2 comma 8.
And
then that would equal 9, or 10.
And
yeah, and then you would add 2 plus 8, and that would equal 20.
Yeah, and then I say and. What else?
Oh, okay, sorry.
If I have x being 1,
it would be, and then you'd have to have y being 9.
And then if I have a 3,
you'd have to have 7.
What if I have x being 10?
That'd be 0.
0.
Yeah.
And then it can go on an even fraction, right? So if I have, honey, if I have like a half for x,
yeah,
then what do you have? 9 and then half. If I have a 0.1, you will have what? 9.9 to have 10.
Okay.
Right?
Yeah.
What if I have a negative 2 for x? You will have 12.
Yeah.
What if I have negative 10? I will have 20. So it goes on and on. So here's the thing. When you have one equation with 2 different variables, there must be an infinitely many solutions. So looking here, even though they give you 2, actually they are the same. They look different, but they are same. It's like if I give you 1 over 2 and then I have 2 over 4, they look different, but they are equivalent to each other.
Yeah, they both equal half.
Just like that. So in this case, the next time when you look at the questions like that, you look at it and like, wait a minute, if I multiply by 3x, 21, oh, okay, they are exactly the same. Then we don't have to do any of this busy work. You just to say what? Infinitely many solution. That's the answer.
I have to go back to finish my essay, but I can be back to finish this later.
Leave it here and then come and see me this afternoon.
All right, thank you.
Okay. Yeah, that's
infinite
it.
Wrong.
Woo, that was long.
That was a rough
And
one.
then, you know what, I apologize because I did not even think about it, okay? And then when we hit here, where was it?
Right.
When you say y is equal to 0, I'm like, no, there's no reason. 0 can be one of the solution, right?
Yeah.
But there's no reason to believe y needs to be always 0. Y can be any number, okay? So that's why I know you hate those tedious work. I hate that. But instead of just giving, oh yeah, this is the final answer, I want you to actually feel, experience, okay, we can go on forever, even though it's tedious. So next time, before you get busy, look at it and then see if that's the case or something like that.
Okay.
Okay.